Can we reverse engineer a UFO? For over 60 years the UFO phenomenon has been capturing our imagination. In this time, all attempts at reverse engineering the putative craft have been futile. During the first decade or so, many researchers were inspired to work with the stereotypical disc shape, and many attempts were made to develop prototypes of a flying disc while studying its aerodynamics. All that has changed now. Recent discoveries have finally paved the road to the reverse engineering of the UFO. In the 60s, we faced two deal breakers with the UFO phenomenon. We had no answer for lift and no good answer for energy supply except a hand wave at fusion energy. We did have an answer for motive power and controls in the form of magnetic field management, provided the craft was light enough and/or the generated magnetic field was strong enough. Computer power sufficient to tackle this type of configuration was certainly on the horizon then. Today we can reverse engineer the UFO as a design concept and catch up to the implementing technology. First consideration. The craft is a magnetic field exclusion device. This is extremely important because that is the source of lift. We know that this can be achieved from our experience with a block of superconducting material. It follows that a skin of superconducting material will exclude external magnetic fields. From then on, the engineering is about craft density, and both the sphere and the flattened disk optimize craft density. Thus observation is confirming the nature of the source of lift and no new physics is called for. A superconductor has the ability to carry electric current without dissipation. The perfect diamagnetism of a superconductor makes it possible to levitate magnetic objects. Superconductivity, as we currently understand it, requires that the material be maintained at very cold temperatures. An excellent analogy is that of a balloon. It has extremely low density compared to the surrounding atmosphere. We can surmise that the craft is set to float without motive power outside our atmosphere. This also infers that the small craft we observe are necessary for deep penetration into the atmosphere. It takes a fair bit of energy to get down to ground level. The flip side of this is that very large motherships will exist in order to have a very low craft density. These motherships are able to develop the power to accelerate in the interplanetary areas where magnetic field strength is much lower. We now know that a first prerequisite must be a skin containing a laminar layer of superconducting material. This also infers an adjoining layer, both under and over, that is magnetic solid-state refrigeration, SSR. We can assume for now that each layer is a few atoms thick. Powering this up will exclude the ambient magnetic field and provide ferocious lift on the Earth's surface. So how close are we to having the right materials? Scientists have been experimenting with superconducting ceramics for over 20 years. Other types of superconducting material are popping up in the labs all over the globe. If we decided to manufacture a layer of such ceramic today, we likely could do it without much trouble, but getting the right temperature profile could be a lot harder. I recently reported on the discovery that superconductance can be achieved at the interface between metal and insulator at up to 30 kelvins. Superconducting layer. The new research involved a lanthanum copper oxide compound that can be doped over a wide range of compositions, which was used to study a potentially new mechanism of superconduction. A substrate of LaserQO4 was used, and an epitaxy technique grew atomically perfect thin films of three derivative compounds, an insulator and a metal that show no superconductivity, and a superconducting variant with a transition temperature, Tc, of 40 K. By growing literally hundreds of combination of interfaces and film thicknesses, the researchers were able to observe superconduction at different temperatures, including superconduction at the metal/insulator interface. While there is no definitive explanation available for this interfacial superconduction, it opens the door for further research into engineering superconductors out of non-superconducting materials. The small length scales at which the superconduction occurs may make it appropriate for micro and nanoscale devices. Nature 455, 782-785, October 9, 2008, doi 10.1038/Nature 07293, received June 15, 2007, accepted July 25, 2008, high-temperature interface superconductivity between metallic and insulating copper oxides. This first discloses that we are working on the problem at the atomic layer level, which is surely what the idea of a working skin implies. It also suggests that a working layer need only be a couple of atoms thick. This makes the cooling task far more tractable. One could even envisage a mechanical system if it ever came to that. Next we have this recent note from a lab in France that I covered in this post. Refrigeration layer. Nanocomposites produced from metallic glasses could make promising magnetic refrigeration materials, according to new work by scientists in France. The materials are as good as the best currently available magnetic refrigerants with some added advantages. Refrigerators using such materials would be environmentally friendly and more efficient than existing devices that rely on a vapor cycle. Magnetic refrigeration is an environmentally friendly cooling technology, unlike the gas compression refrigerators used today, team member Stéphane Gorce of the Institute of Condensed Matter Chemistry of Bordeaux, ICMP-CNRS, told nanotechweb.org. It uses no ozone-depleting, hazardous chemicals or greenhouse gases, such as hydrofluorocarbons used in conventional refrigeration systems. Moreover, the energy efficiency can reach up to 60%, compared to just 40% for the best gas compression refrigerators. New refrigeration system based on magnetics more economical and quieter than current technology. Update. Science Daily, February 12, 2009, your refrigerator's humming, electricity guzzling cooling system could soon be a lot smaller, quieter, and more economical thanks to an exotic metal alloy discovered by an international collaboration working at the National Institute of Standards and Technology, NIST's Center for Neutron Research, NCNR. The alloy may prove to be a long-sought material that will permit magnetic cooling instead of the gas compression systems used for home refrigeration and air conditioning. The magnetic cooling technique, though used for decades in science and industry, has yet to find application in the home because of technical and environmental hurdles, but the NIST collaboration may have overcome them. Picture. Magnetic cooling relies on materials called magnetocalorics, which heat up when exposed to a powerful magnetic field. After they cool off by radiating this heat away, the magnetic field is removed, and their temperature drops again, this time dramatically. The effect can be used in a classic refrigeration cycle, and scientists have attained temperatures of nearly absolute zero this way. Two factors have kept magnetic cooling out of the consumer market. Most magnetocalorics that function at close to room temperature require both the prohibitively expensive rare metal gadolinium and arsenic, a deadly toxin. But conventional gas compression refrigerators have their own drawbacks. They commonly use hydrofluorocarbons, HFCs, greenhouse gases that can contribute to climate change if they escape into the atmosphere. In addition, it is becoming increasingly difficult to improve traditional refrigeration. The efficiency of the gas cycle has pretty much maxed out, said Jeff Lynn of NCNR. The idea is to replace that cycle with something else. The alloy the team has found a mixture of manganese, iron, phosphorus, and germanium is not merely the first near-room temperature magnetocaloric to contain neither gadolinium nor arsenic rendering it both safer and cheaper but also it has such strong magnetocaloric properties that a system based on it could rival gas compression in efficiency. Working alongside, and inspired by, visiting scientists from the Beijing University of Technology, the team used NIST trademark neutron diffraction equipment to analyze the novel alloy. They found that when exposed to a magnetic field, the newfound material's crystal structure completely changes, which explains its exceptional performance. Understanding how to fine-tune this change in crystal structure may allow us to get our alloy's efficiency even higher, says NIST crystallographer Qing Huang. We are still playing with the composition, and if we can get it to magnetize uniformly, we may be able to further improve the efficiency. Members of the collaboration include scientists from NIST, Beijing University of Technology, Princeton University, and McGill University. Funding for the project was provided by NIST. They have developed a metal glass that acts as a magnetic solid-state refrigerant, SSR, with an effective range of around 100 K. This is extraordinary compared to prior experience which achieved only 10K. Thus we can envisage a sandwich of 3 to 4 layers of metal glass with an operating range of as much as 300K to 400K, which is more than enough to strip heat away from a superconducting core layer. The idea of a multi-layered sandwich of specially engineered metal glass and a superconducting core is completely viable. We have found the first examples, and it is a matter of chasing down the right combination to manufacture a skin for a magnetic exclusion vessel. It will not be easy to convert that knowledge into a manufactured product, but we know now that this can be done. Energy storage. Then there is the problem of energy storage. Here EE-Store is leading the way with ultracapacitors storing energy in micron and nanometer-sized balls. The astounding thing about this research is that the first published application patent was for a battery skin inside body armor. See link. These recent patent disclosures have opened the door to a superior energy storage system that allows the fabrication of a battery skin. This means that this skin can be added to the inside of the exclusion skin of a UFO, providing a massive energy storage capability. This is particularly true as we advance this technology with progressive improvements. One last addition to this skin sandwich is an outer layer of graphene above. This is a newly discovered substance and represents a new form of our old friend carbon. It is the strongest known material and forms a flat layer of tightly bound carbon atoms that will conduct electricity. It will be on the outer surface of the skin and naturally accommodate externally generated magnetic fields and currents. It may also absorb visible light as does graphite and carbon itself. Again, here is my link on the subject. Therefore, our working skin can be assembled in layers of at least from the outside inward of graphene, SSR, ceramic superconductor, SSR, and EE-Store energy storage skin. We can also anticipate an additional layer of circuitry and metal glass on the inside. It should be even tough and strong. The graphene layer was suggested by observations made regarding the Pomer disk, which is most likely the best known report of a likely lost component of an UFO. The observations are over a decade old and it was made long before graphene was discovered in 2004. Yet I recognized the importance of the Pomer observations because of the outer graphene and the interior metglass and an open edge that revealed layering to the eyeball. I have long anticipated such layering of ceramics and metal glass, but it is just now that the practicalities are been addressed in our labs. I imagine that I was the only reader not surprised by the reported description of the Pomer disk. We now have our magnetic field exclusion device that rides the magnetic fields of Earth and the solar system like a soap bubble. The remaining question is how to accommodate magnetic fields generated by the electron flow through the other layers. It could even be that the magnetic exclusion can be used to facilitate the refrigeration aspect. All of this will be exciting work for the lab. There is obviously plenty to do, but it is now directed and understood. And yes, we need to round up the Pomer disk and other artifacts if possible because it surely is a shortcut. Second consideration. For our next trick we need to move this bubble around. Here at least we have an option. We need to run a powerful current in a ring around the craft orthogonal to the desired direction of motion. This will induce a strong magnetic field as a torus above around the current ring. We obviously need to vary the direction of this ring to guide the motion of the craft as the induced field reacts with the external magnetic environment. At this point it is natural to assume that we are describing physical current guides, but recall that the graphene surface is very conductive even if it is adjacent to a magnetic field exclusion surface. It becomes easy to also envisage a strong current flow from the top and bottom around the rims, creating very powerful magnetic fields with a fair bit of directionality control. We postulate that any magnetic field configuration imaginable can be generated around this bubble without being too difficult from an engineering design perspective. This is a bit of a hand wave, but we all know that we have been dealing with exactly these issues for 200 years. It is a nice engineering challenge to arrive at an elegant solution. Third consideration. We need a lot of electrical power to operate this craft, and that means access to a small compact fusion power device. The obvious device protocol that satisfies our needs is the focus fusion device, now been advanced. It consists of an anode barrel surrounded by 8 copper posts acting as cathodes, see below. A pulse of current originating in a capacitor jumps from the cathode into the anode, forming a strongly wound bundle of plasma filaments that arrive at the bottom of the barrel, forming a plasmoid that contains the reactants and hurls them together at the temperatures needed. Work has begun to fine-tune the device and discover its limits, but a pulse of ions generates a current pulse in one direction and further energy must be bled of in the other direction. It is all very promising and actually looks just like what the doctor ordered. A next stage may see graphene replace copper in the cathode and anode, which should be a major improvement. Again, I reported on the device and also posted the company's slideshow in the second link. The slideshow is very compelling and it is easy to imagine the copper bin replaced by graphene, which is almost a superconductor in its own right. It is worth the effort to work through each slide. We have a prospective device that can be built small enough and powerful enough to provide all the necessary power to operate this UFO design. It apparently works now, but needs to be brought up to and past break-even, as is true for all fusion systems to date. This still looks like it is very close to operational success and deserves maximum support. Conclusion. All the ingredients for an operational UFO are today in the laboratory been advanced at a very quick pace. We have already mastered digital control systems and the related hardware. We are about to master the manufacture of multilayered atomic skins able to produce the needed characteristics. And the direct fusion device needs a major research drive using graphene in its construction. These problems are hardly trivial, but they are very close to solution, if not in fact solved. Most importantly, we now know what we must focus our research efforts on and why we must. Once we master manufacture of the skin, it will be possible to build spacecraft of very large size able to lift off the Earth on powering up. It just will not be able to land quite so easily. It will be necessary to develop small craft such as the observed UFOs in order to get down to the surface. That will likely be quite a bit more difficult than the larger craft and will possibly delay a full deployment of the technology. So I ask you, can we do this? Another question I would like to ask, if we have been, does this just mean we are just reinventing another inventor's idea? That brings up another question: are aliens really just humans? Stay paranoid, my friends.